Hello everybody, STEM Choir here with lesson 8.1, Graphing Quadratics. So we have our quadratic function here, and we have to put it onto our graph. So to do this, we need to find a point called the vertex point. So the vertex is basically going to be the middle point of our graph, or the point of, or the axis of reflection, or the axis of symmetry. And to find this, we're going to do a formula called negative b over 2a. So negative b, so this value is going to be our b value, and then the coefficient for the first x squared value is going to be our a value. So this is just going to be 1. So negative b, so negative 4 over 2 times 1. So this is just going to be negative 2. That means x equals negative 2 is going to be our axis of symmetry. And our vertex point is going to be on that axis. To find our vertex point, we're going to set this whole thing equal to y. So y equals, and then we're going to plug in negative 2 for our x value, because on our vertex, negative 2 will be our x value. This is going to be how we find any point. But our vertex point, or the axis of symmetry point, is the most important. It's going to be negative 2 squared plus 4, negative 2, plus 3. This is going to be, negative 2 squared is going to be 4, plus 4 times negative 2 is going to actually be negative 8, and then plus 3. And then this is going to equal 4 minus 8 is negative 4, negative 4 plus 3 equals negative 1. So y equals negative 1. So that means the point for our vertex is going to be negative 2, comma negative 1. That's our vertex point. So let's plot that. So let's take out the axis of symmetry, and let's plot negative 2, comma negative 1, which is going to be right here. Now that we have this point, we can get started on mapping out the rest of our graph. Let's erase all this. So the basics to graphing is we need 5 points. So let's make a table. X, y. So negative 2 is going to be negative 2, negative 1 is going to be our first point of our 5. So 5 points are the best way to do this. So the next points are just going to be one above both the x and the y. So it's going to be 1 above negative 2, which is going to be negative 1. 1 above negative 1 is 0. So that means our point is going to be here, which is going to be negative 1, comma 0. And then below, it's going to be 1 less than x, which is going to be negative 3, but it's still going to be 1 more than y. It's going to be 0. So these two are, the y values will be the same, and then this will be 1 above, and this will be 1 below. And that's how we find the next 2 points. So it's going to be negative 3, comma 0, to put the point there. These are also our x-intercepts, or zeros, that we can find by factoring out this equation. Next, we have to find our last 2 points. And that's all we need to graph, because then we can just draw it after that. So our next 2 points are going to be 1 more above, so it's going to be 0. So that's going to be 1 more above, 1 more above, so plus 1, and then negative 4, which is going to be 1 more above, or minus 1. But here is where it gets tricky. We're going to do 4 more than our base one, or 3 more than our other one. Why do we do this? Because it's a quadratic. So quadratic means, it says x squared, so it's always going to be squared. So here it's 1 squared, because we're going one point after, so it's going to be, and 1 squared is 1. But the next is 2 squared. 2 squared is 4, so that's why we have to go 4 more up. And that's basically the math behind it. So negative 4 and negative 4, comma, and then we have to go 4 more, which is going to be 3. So it's going to be plus 4, or 3 more than this. and it's going to be the same on the other side. This is a reflection. Just like I said that the vertex points on the axis of symmetry, all of these points are reflection of that axis. So it's going to be the same on both sides. So that means it's going to be 0, 3 and negative 4, 3. So now that we have our 5 points, it's going to be really easy to draw this graph. We're just going to go up, and we're just going to go in this way up infinitively. And that's how you graph a quadratic.